Alright, I think in the previous video I told you we were going to go over problems number 4 and 5. A couple new videos. I changed my mind. I'm going to do numbers 4, 5, and 6 all in one video, right? A little bit more information, a little bit less time. Alright, so what we're going to do is we're going to plot a point, and then we're going to plot a new point that's symmetric to the original point with respect to the x-axis, the y-axis, and the origin. And we'll just do one example for each problem, not all 3 examples for all 3 problems, okay? Cut our work down a little bit. So for number 4, our original point is negative 7, 4. I'm going to use part A, alright? I'm going to plot a point that's symmetric to negative 7, positive 4, with respect to the x-axis. And in doing that, remember our original point xy, that will yield a new point, which will be x negative y. Alright, that new point will be symmetric to the original with respect to the x-axis. That means this negative 7, positive 4, our new point will look like negative 7, and then the opposite of positive 4 is negative 4. Alright, so let's plot those 2 points, see what they look like. Negative 7, positive 4 are original. That means we would move left 7 and up 4. Roughly something like this. Alright, left 7, up 4. I'm going to label it. And then our new point that's symmetric to it with respect to the x-axis would be negative 7, negative 4. Which means we move left 7 again, but this time down 4. And our new point would be roughly right here. I'm going to label it also, negative 7, negative 4. And you can see that our new point is symmetric to the original with respect to the x-axis. It is as if our original point reflected over the x-axis. Alright, let's move on to number 5. We're going to take negative 8, negative 2, and we're going to plot a new point that's symmetric to it with respect to the y-axis this time. That means our original xy will yield a new point that looks something like negative x, positive y. In other words, our original point, negative 8, negative 2, will get a point that looks like I want the opposite of negative 8. That would be positive 8. But our y value will stay the same, which will be negative 2. Alright, remember the negative sign in this case means the opposite. So if there is no negative sign, like right here, notice there's no negative sign on the y, that just means we want the original value, not a positive value, just whatever the original value is. Okay, so let's plot negative 8, negative 2. That would mean I would move left 8, down 2, something like this. And if I want to plot a new point that's symmetric to that in respect to the y-axis, I would plot positive 8, negative 2. That means I would move to the right 8, down 2. And that would look something like this. And you can see that our new point, it looks like it was been reflected over the y-axis. Alright, that means symmetric with respect to the y-axis. Alright, last but not least, let's talk about 6, negative 3. That means our original point xy, some point that is symmetric to it with respect to the origin would look like negative x, negative y, which means our new point would be the opposite of positive 6, which would be negative 6, and the opposite of negative 3, which would be positive 3. So plotting our original 6, negative 3, that's right 6, down 3, something like that. And our new point, negative 6, positive 3, looks something like this. Gives us a pretty good illustration of a point that is symmetric to another with respect to the origin. Alright, good luck with your homework.